welcome to NET303. This is building your global wide area network using AWS. I'm James Devine, I'm a Principal Solutions Architect, and I'm joined by Sid.
I'm Sid, I'm a Principal Solutions Architect as well.
Awesome, so thank you for being here at this hour. There are plenty of other places you could be in Vegas at this time, so Cloud WAN is personally where I think the best place to be is. So we'll start with a brief agenda, and we're going to go talk about the evolution of Cloud WAN and WAN in general and how we got to where we are today. Talk about the AWS services that enable you to build your global WAN. Then we'll deep dive on Cloud WAN specifically, go through a demo, and then answer all of your questions and answers. We're the last session here, so we'll stay as long as there's questions. We'll make sure we get those answered. This is a 300-level session, so we'll make sure to introduce topics, but we will go fairly deep. We'll be doing packet walks, so we'll be getting the nerd on there. Hopefully that's OK. So if we think about the evolution of a WAN, a wide area network is nothing new. They've existed for quite some time. You have your on-premise locations, your remote offices, and your end users, and you connect them all together. This has typically been done either through building out your own type of MPLS network or relying on a third party or some combination thereof of having the physical infrastructure, dark fiber, and this is typically slow to provision, slow to change, your typical fixed infrastructure that isn't all of that flexible as you expect in a cloud environment. And this typically tends to work. You have to plan through your lead times and your connections and set everything up. But as you start to extend your applications into the cloud, you end up with more connectivity requirements and connecting into your cloud environments, your VPCs that could expand the globe. And that connectivity pattern looks quite different in the cloud than it does in your on-premise environment. You're not having to build and manage all of those individual links. And as your apps move to the cloud actually becomes the center of gravity. So kind of the better way to do this is to make the cloud the center of the network instead of making it kind of a branch that you're connecting to. As more apps move, you have higher bandwidth requirements, you might need dynamic bandwidth or just the infrastructure that AWS brings to the table. So this is definitely a way to grow your network into the future. So if we look at what this looks like, we have VPCs across the world. This is something you can do today, even before our services for quite some time. And then you have your data centers and branch offices. And then you build a wide area network that extends the globe. Easily as that through the AWS console or CLI. You connect in all of your sites to this Cloud WAN. And then now we can have VPC to VPC communication, leveraging the AWS backbone, nothing to do or configure there other than just having a connection and attachment to the Cloud WAN. We can do VPC to site connectivity and have that end-to-end connectivity. We can also facilitate site to your edge location connectivity. So you have that convergence of what would typically be your MPLS network that you're deploying. That can all be moved into the cloud. This all rides over the AWS global backbone, multiple 100 gigabit a second connections, and Sid will be coming up and talking through more about what that looks like.
All right, thanks, James. Now, physical infrastructure is what underpins the cloud-based WAN network you'll create on AWS. Now, I have listed some key attributes here. Use these as guiding principles to frame your opinion as we talk about the AWS offerings. AWS Global Network is redundant 100 gigabit Ethernet network backbone, often providing many terabits of capacity between AWS regions, and it connects 6 continents. You can use this physical infrastructure for your own WAN connectivity, and with dynamic bandwidth allocation, you can scale up and down as your global routing requirements change. Now, all traffic on this global network between our AWS regions and data centers is completely encrypted at physical layer using MACsec and optical encryption. And this is irrespective of which AWS service you're using on the top. You can connect your on-premises data centers to this global infrastructure using dedicated fiber circuits, and you leverage AWS Direct Connect service for that. This is how it works. On the right, you have your corporate data centers. On the left is the AWS Global Network. Our job is to connect them. For that, you meet us at AWS Direct Connect locations. These are third-party colo facilities where AWS has presence. These Direct Connect locations are connected to the AWS global infrastructure through redundant fiber links. You set up last-mile connectivity from your data center to the Direct Connect location. Now go to the AWS console or use CLI and request a Direct Connect connection. We give you a letter of authorization using which you can set up a cross-connect. This enables end-to-end physical connectivity from your data center to the AWS global backbone. You can connect to us at over 100 plus Direct Connect locations worldwide. Now for resiliency, it is recommended that you connect to us at least 2 different Direct Connect locations. Now let's talk about the AWS services, which through software-defined networking will allow you to create your WAN network over the AWS physical infrastructure. Now again, I've mentioned some key attributes which we will use as guiding principles to compare and contrast different options. Option 1 is VPC peering. VPC peering is the most fundamental way of connecting 2 VPCs together. VPC peering can connect VPCs within a region as well as across region. This connectivity is 1:1, which means you need to connect every VPC to every other VPC. And the same logic applies for hybrid connectivity as well. Your on-premises routers create BGP peering relationship with AWS Direct Connect Gateway, which is a highly available distributed router, but this Direct Connect Gateway needs to be associated with each and every VPC. You need to create VPN connections to each and every VPC. Now, VPC peering is very fundamental in what it offers. It just connects to VPC. There is no network segmentation. There is no transitive routing. But the simplicity where its strength lies. VPC peering uses native VPC constructs to bridge 2 VPCs. So there is no additional gateways, no additional hardware, no bottlenecks, and no additional hourly costs. But for something better from a manageability standpoint, scalability standpoint, feature and functionality standpoint, let's move to option number 2, which is using Transit Gateway. Here, we get rid of the mesh design and bring in a hub and spoke model where Transit Gateway becomes the regional hub of your network. All the different networks connect to this Transit Gateway, and the Transit Gateways connect to each other using cross-region peering. So we'll connect our VPCs to the regional transit gateways, our direct connect connections to the regional transit gateway, as well as VPN. Now, Transit Gateway also supports creating GRE tunnels to SD-WAN appliances. And if you have remote users who want connectivity to this global infrastructure, they can do so by using client VPN endpoint. Now, Transit Gateway has routing segmentation. Transit Gateway supports transitive routing, and it also has unique features like multicast and private VPN. So far, so good. Now, let's look at a Transit Gateway design where you have multiple regions, multiple route tables. Now, you can associate 5,000 networks or connect 5,000 networks to a Transit Gateway. Now, for each network you connect, you need to create an attachment. You need to associate to a route table. Then you need to propagate the routes into one or more route tables. And all of these are manual tasks. In an agile world where customers are adopting net DevOps, people are trying to automate the steps using custom scripts and Lambda functions. Next, if you want to connect your transit gateways across region, you need to create a full mesh of cross-region peering. For that, you need to create a peering attachment. You associate that to a route table. Now, keep in mind that you only create one peering connection per transit gateway. So if you wanted to attach individual route tables, for example, you wanted to say, hey, prod route table in US East 1 should talk to prod route table in US West 2, and dev to dev, but I don't want prod and dev talking to each other across regions. Well, for that, you'll have to write static routes, and that's not easy. And you may or may not be able to achieve the security model you're looking for. So from an automation standpoint, there's much to be desired, and we have heard the feedback, hey, AWS, can you automate these stuff for us? Extensibility, adding new regions is creating the entire thing, like attachments, peering, etc., from scratch. What you're getting here is a distributed pane of glass because Transit Gateway is a regional service. So you're defining regional routing and security policies and somehow trying to bring them all together, which is not easy. So what if we could take this Transit Gateway peering mesh and create a global service on top of it, where through a single configuration pane, we can define globally consistent security segmentation. We can have tag-based automation, where you tag your attachments and they automatically associate to the right segment. You can define policies, and the route sharing automatically happens behind the scenes. For example, here, a blue and green routing segment can talk to each other. And finally, what about automating it end-to-end for any kind of changes you make to the network? You might have guessed it by now. This is what we are talking about, right? It's Cloud WAN. So that's the value which Cloud WAN provides. Cloud WAN is a service which makes it really simple to create global WAN networks on AWS and connect your on-premises data center, branch offices, as well as cloud resources. You don't have to go to regional consoles anymore. You get a global configuration pane where you write network policies which define your intent, and these network policies take care of the provisioning of the network infrastructure as well as any changes to it. So let's see what Cloud WAN's different components are and how do you go about creating your own WAN network using Cloud WAN. The first thing you create is a global network and a core network. Now, global network is a high-level container for all your network objects, and this includes Cloud WAN components as well as transit gateway, regional transit gateways. Core network is the Cloud WAN component which exists within your global network, which is fully managed by AWS. And it consists of core network edges. These are regional Cloud WAN connection endpoints deployed in every region where your core network extends into. Next, you need to define and deploy a network policy. A network policy is a policy document written in JSON, or you can also use GUI to do that, which defines the global configuration of your network. There are several components to it. First, you need to define which regions you want the core network to be deployed in. This is where your regional edge, core network edges will be deployed. Next, we define segments. Segments are isolated routing boundaries which are globally consistent. Now, in a traditional network, you can think of segments as VRFs, virtual route forwarding tables, or IPVPN over MPLS network. Within a segment, you can define which regions it extends into. This is optional. So here, for example, you can see the production segment is only available in region 1 and 2. By default, if you don't mention this, the segment will extend into all the AWS regions where your core network is configured. Next, you define a segment routing behavior. So by default, you can have all the networks connected to a segment talk to each other, like typically you have in a VRF. Or you can also isolate them. So you can say, hey, I don't want any of my network connected to a single segment talking to each other. Finally, you can write segment actions to share routes between segments. So here, for example, I'm saying, hey, hybrid can talk to development, but I'm isolating my production from all the other segments. Additionally, you can write static routes for advanced routing configurations. And finally, through attachment policies, you can automate how your networks get associated to these segments. You can do that using tags or metadata, and we'll look at examples of how this is done later in the slides. You can also have a human verify this attachment request before the automation kicks in. Now, the only thing left to do here is create and tag attachments. Now, attachments are very similar to how you have been working with transit gateway attachments. So we have VPC attachments to attach our VPCs to a core network. We have VPN attachments to set up IPsec VPN connection to your remote offices over internet. Core network also supports creating GRE tunnels to your SD-WAN appliances. This is called connect attachment. And finally, your remote users, if they want access to the Cloud WAN core network, they can do so by using a client VPN endpoint. Now, to connect your Direct Connect locations or your on-premises data centers via Direct Connect to Cloud WAN, you will have to use Transit Gateway today. So we don't support the native attachment yet. And James is going to talk about the roadmap towards the end of the presentation. But here we are attaching a Transit Gateway to our core network, which in turn is connected to your on-premises data centers via AWS Direct Connect. Next, we go ahead and tag your attachments. And based on the policies we have defined, Cloud WAN is going to take care of of the rest. So it will map the attachments automatically to the right segments. It's going to learn the routes, so VPC siders or your on-prem routes via BGP, and push them into the segment route table, as well as share them across segments. Once that's done, all that's left is to route your traffic. So you can route your traffic from a VPC to another VPC. You can route traffic from on-prem here through IPsec VPN over core WAN to SD-WAN remote sites, as well as from on-prem to a VPC. Right? And all of this routing depends on how your route sharing has been configured. Now, there's one traffic flow which I want to deep dive into. And this is from your on-prem networks, on-prem data centers to another on-prem data center. So here, traffic is sent from your data center to a Direct Connect location, to core network edge in region 1, then to core network edge in region 2, down to Direct Connect location, down to your data center. Now, unless you have a specific reason of sending a traffic up to 2 regions, like traffic manipulation, inspection, this adds latency and cost. A better way is to use Direct Connect infrastructure and send the traffic from your data center to another data center using the shortest path first. And this is exactly what SiteLink enables. Here, there is no regional dependency, right? The traffic is sent using our AWS border network and backbone directly between your data centers. So with AWS Direct Connect SiteLink feature, you can connect your corporate data centers to the nearest Direct Connect location. And then with SiteLink enabled on Direct Connect Gateway, your traffic can be routed from any data center anywhere in the world to another data center. Right? This is supported in all commercial AWS Direct Connect locations except China. Turning SiteLink feature on and off is extremely easy. If you already have Direct Connect connectivity to AWS, it's just a flag which you need to flip. You can do that through the console or through the CLI. Now, when would you want to use Direct Connect? If you already have a primary backbone through some of the top service providers and you wanted a backup backbone for your data center connectivity, you can use AWS Direct Connect SiteLink. Or if you don't have one, go ahead and use AWS Direct Connect SiteLink as your primary backbone. It's also a good way to connect to your partners, acquisitions, people you're doing business with. Now, everyone is migrating workloads to AWS, so there's a very high chance that the partner you're doing business with already has connectivity to AWS. Just leverage that. You don't need to create any private circuits to your partners. You can leverage your connectivity to AWS, they can leverage their connectivity to AWS, and you can bridge them together using AWS Direct Connect SiteLink. If you want to learn more, I did a presentation on SiteLink at Reinforce. Feel free to check that. So let's recap the AWS services which we just talked about. VPC peering, a fundamental way to connect VPCs together. No additional gateways, no additional hardware, no additional bottlenecks, no additional hourly costs. If you just want to connect few VPCs together, that's the way to go. Now, AWS Transit Gateways enable scale. You can connect up to 5,000 networks. You can create route tables. You have additional functionality like multicast and private VPN. Now, if your global presence is limited, or if your route segmentation and route sharing across regions in a global way is pretty straightforward, not very complex, then Transit Gateway is a great way to get started and build your networking on AWS. If all you want to do is connect your data centers together through high-speed, low-latency network backbone, AWS Direct Connect SiteLink is your answer. But for everything else, Cloud WAN gives you this AWS feature-rich WAN service on AWS, where you can connect your data centers, on-prem branch offices, as well as cloud resources. Now I'm going to hand it over to James, who will dive deeper into Cloud WAN and related architectures.
OK, now we'll dive a little deeper on Cloud WAN and some of these architectures that can enable this. We'll talk about the network as policy and dive into some policy, talk about segmentation, building out additional architectures, deploying at scale using Cloud WAN, and then the visualization that we get from leveraging Cloud WAN to build out our global network. Starting out with network as policy. So everything in Cloud WAN is going to be a policy document. We can see on the right, it's a fairly simple JSON document. If you're not familiar with JSON or it's something new, then there's the GUI, and the GUI works just as well and will generate those policies on your behalf. So regardless of which path you choose, there's going to be a JSON document that's versioned and controlled. And it can be fairly simple. So you could start off in the console, building out, and then use that to get comfortable with the JSON format, and then download that document. There's a path there for everyone. Digging in a little deeper to what this JSON document looks like, fairly simple. We have a core network configuration. We then define ASN ranges, autonomous system numbers. So each region will get a unique ASN from that range as you provision additional regions for your core network. We then define our segments, and we can see here a segment can be as simple as 2 lines of code here, where we determine whether it's going to be auto-accepted and the name. That's as simple as it gets. We could also include an optional description, but it's that simple to define a segment globally. We then define segment actions. So here we're defining a share action. So our hybrid segment is shared with our development and production. So any routes that come into the hybrid segment will automatically propagate to our development and production segments, and we'll be able to have that end-to-end communication. We then define an attachment policy. This has a rule number. They're evaluated lowest to highest, so you want to have your most specific rules up front, and they're applied in order. So we'll start, in this case, rule 100, and this says if a association is tagged with segment, automatically attach it to the segment called segment in this example. So really easy to define this and have policy dictate your global infrastructure and how your traffic is routed. Looking at the policy, we have versioning built in. So this defines your entire global WAN. There's a live and latest config. If you're familiar with routing and come from a network engineering background, very similar concept here, where you have a live config and then you have a latest config. You can also roll back and roll forward, and you have that type of versioning built in. So it's easy to roll in and out. Another nice thing is the control plane is all public through APIs or the console. So if you did make a change that caused some bad things to happen, you could roll it back quickly without having access to those regions or routes that it controlled. There's also a validation built into the console and CLI where we'll check to make sure the document is valid, the JSON's formatted properly, and that there's no conflicts in it. If you're using the GUI, we can see in this diagram here where you can actually see the changes and what's changed in the JSON and what's going to be applied before you ever go and apply it. So it might be that another network engineer or another member of your team has gone and made a change or adjustment. You can go and validate that before you actually deploy it to your global WAN. And we can see here through the console, it's pretty easy to roll back, roll forward, edit, delete, and even download the policy documents. So you don't need to be an expert in JSON or the programmatic side of it, but if you are, that's all the easier to automate your entire global network deployment. Now that we've talked about creating our network through policy, we're going to talk a little bit about segmentation. So segmentation could be a loaded topic, why segment? But if you think about it, kind of how you have security groups and NACLs as your security layers of control, what you get with the segment and in segmentation is an additional layer. So it's peeling back the onion and making sure that your network is secure at the network layer. So if you can't route to something, it doesn't matter any of those upstream controls, there's no route to the traffic. You're not going to be able to get through. So it's an additional layer of control. And like Sid was saying, they're purpose-built. Think of it like a VRF, virtual routing and forwarding, a separate route table instance for each of these segments. You can segment at scale, so 5,000 attachments. We can have up to 20 segments on a core network. And I think the real power here is tagging to automate. You're not going through and saying this attachment belongs to this segment. You can say if I tag something as production, automatically make it production. So you can really deploy at scale and have that network correctness without having to manually go in and define that, which can be very difficult within a region, especially when you go multi-region. So we can see the segments here, again, fairly easy to define. The acceptance here, so there's a workflow process. You can either carte blanche just accept as soon as you attach to something, go ahead and start routing traffic and associate it with a segment, or you could choose the option to say false. You want a manual process where either a human needs to go in and say, I approve this explicitly, or you have a programmatic action that says the policies are proper, go ahead and attach this. So you have an additional control and gate to keep before you get access to a segment. This also works through our console, so you can go in and visually edit these policies and define all of this through a simple GUI very easily. If we think about some of the segmentation options here, this is a view from the console. It could also be a JSON document as well. Here we specify a name. I'm calling this prod. And then we specify an edge location. By default, a segment will expand all of the global configuration and every edge location. You can explicitly say for regulatory and compliance, EU can only access this segment. So you can get really granular at the region level to your attachments to to the Cloud WAN and make some of those regulatory and compliance options built into your network infrastructure, which is kind of unique. Here, the require acceptance, which we were talking about, that you can choose whether to require that or not. If you want an additional layer of control, certainly do that. If not, then that's one less step. We can also go ahead and isolate attachments. We might not want attachments in the same segment talking to each other. A simple checkbox here, and then we isolate all that traffic, and each segment is individual. Kind of limits some of the utility, but there might be use cases to leverage that. We can also filter out our segments, and this is where when we were talking about segment sharing and learning routes from other segments. There's either an allow all, we can allow selected, or deny selected. So here we're showing allow selected, and then from this drop-down list, you choose the segments that you're allowed to talk to. So maybe prod can talk to hybrid or talk to egress or ingress, but not to dev. We can codify that through this segment option. We also have segment attachment policies. This is when we take our attachments to our core network and determine what segment they'll get mapped to. So there's a robust policy framework. We started with the rule number, so lowest to highest is how they're ordered. So you might want a really high-level default rule that says, if there's no specific rule for this, I'm just going to stick this in a deny all or just egress only, depending on your network policies and your organizational policies there. You have that ability to control the traffic. We then give it a description. This is completely optional. And then we choose what segment to attach this rule to. So here we can choose prod for the segment to attach to for this policy. And then we can either, here we can actually explicitly say, even though the segment might not require acceptance, I still want it to require acceptance based on policy or for whatever reason. And then we can make sure that happens. And then we go and build our logic. This can be and or type of almost like regular expressions where there's multiple conditions and any of them are met, then it's attached. Or you can do an explicit and. So the region is this, and the attachment type is this. You can build a hierarchical type of policy. Some of the conditions you can use, there's the resource ID. If you really wanted to, you could explicitly say, this VPC ID and this VPN ID. Probably lose some of the utility of Cloud WAN if you do that, but that's certainly an option if you need to. You can specify regions and say all attachments in this region must be attached to this segment. You can choose attachment types. Maybe we want all of our Connect attachments and our VPN attachments to be attached specifically to a hybrid segment. That's an option there. We can choose accounts. So if you're segmenting your account structure, and multi-account is pretty much your best practice at this point, if you know what your development account IDs are, you can say all development account IDs are automatically attached to a development segment. And then there's also the name and value tags that you can use here as well. So you can build some pretty novel and complicated workflows here to ensure that segments are mapped in the way that you want them to by policy. And this is not kind of, if you're familiar with Transit Gateway, trying to define this and do this all in route tables can be quite cumbersome. So now we've talked about segmentation and policy. Let's talk about some architectures and how we integrate this into your global network. So first and foremost is Transit Gateway. Transit Gateway isn't going anywhere. Sometimes folks want to know what's going on with that. We're continuing to develop. It's a first-class citizen. But Cloud WAN is going to be where you're going to see more of these global features come to play because Transit Gateway is going to be a regional construct. That's not changing. It exists within a region, whereas Cloud WAN is a global construct which works across regions. So we can integrate with it directly. There's a QR code if you want to see it. There's a blog post that came out recently that dives in even deeper into this architecture. But essentially what we're going to do is create a TGW peering connection from each of our transit gateways to our core network. And then we're going to create something new called a route table association. And this takes a route table from our transit gateway and explicitly associates it with a segment on our core network. So we can repeat this for our dev traffic and then for our prod traffic as well. So now our prod transit gateway routing domain in both of the regions are attached to our prod segment. And this will actually allow north, south, east, west traffic from transit gateways. They can hop through core network. You'll notice here there's also, all the routes are propagated. There's no static routes here. There's no manually adding routes. This is all just dynamic and changes as your network changes. So a lot that we bring to the table here with this architecture. So if we look at what two dev instances talking to each other from Cloud WAN to a transit gateway, we'll have a packet flow out. It'll hit the core network edge. It's associated with the dev segment. We have a route here, and we know those CIDRs are then in transit gateway 2. Traffic will go across that TGW peer to the dev route table on the transit gateway, and from there it's a propagated route, and the traffic will flow directly. So pretty simple, 3-step hop to go from a core network into a transit gateway. This is great for a migration use case where you have transit gateway today, but you're moving towards Cloud WAN, or you just, for whatever reason, need to operate transit gateway side by side with Cloud WAN. We fully support these type of architectures for you. Another big topic, especially as you're building a Cloud WAN, is Direct Connect integration. So here, kind of similar to what you do today, and with transit gateway. So on the left and right, we see nothing kind of too new here, where there's a transit gateway. We have a Direct Connect gateway attached to that has a transit virtual interface, which then connects to AWS's router, and then there's a handoff to a physical location to your router and to your on-premise location. So on the left and right, you'll see nothing new there if you're familiar with the transit gateway architectures. What's new here, though, is we have a transit gateway peering, and here we've created a hybrid subnet, and the hybrid subnet is shared with our dev and prod segments. So any routes learned in the hybrid will automatically go to our dev and prod segments. If you're thinking, the previous architecture, you could do that as well, where you explicitly associate a route table in transit gateway that has the routes that you want to a Cloud WAN segment. But a lot of times we see customers typically aggregate their traffic to on-prem and then break it out on-prem. But depending on your architecture, either is valid. This is just another way to do that. So you see our instance here wants to talk to on-prem from prod. It's going to go to its prod segment route table. And then here we have the on-prem CIDRs, and we know that they're on a transit gateway. The traffic will flow to the transit gateway and then to on-prem through the Direct Connect gateway and the transit VIF. So we have that end-to-end on-prem flow. We know there's additional steps in here. This can be a bit cumbersome. There are some options we're looking at making this easier, and we'll talk about that towards the end when we get to some of the future-leaning capabilities. So a great way to kind of integrate these two today and have that on-prem routing. Another common architecture we see is centralized inbound. There's kind of two camps. Some people love this, some people hate it. If you're a developer and you don't have access to spin up an IGW, this is probably something that you need to work with. If you're a security or network team and you want to control the ingress and maybe none of your VPCs have an IGW, this is the type of architecture that will allow you to expose an inbound VPC and then have all of your other infrastructure be private within your network. So here we have traffic come in from an internet gateway to a public-facing ALB, an application load balancer. This could also be a network load balancer. Either will work. If we wanted to add inspection, we have a GWLB, a gateway load balancer here. This could hop into a gateway load balancer, bump in the wire. We can do deep packet inspection, use third-party firewalls. It could also go to AWS Network Firewall. So you have that extensibility if you want to add inbound with inspection as well. So here we're just showing going directly to an ALB. So then this hits the security segment route table, and then we can see here we've got a propagated route to the dev VPC, and then we'll go directly to the dev VPC to, in this case, an NLB. This could also be an ALB, but NLB for this type of architecture is a little bit more flexible because it's static IPs per AZ and won't change. If you're using an ALB, those IPs could change. There's some Lambda automation to make that work and update those route tables. And then from there, behind the NLB onto your instances or Kubernetes clusters or other containers or infrastructure running your code. On the way back, the dev VPC goes to its route table in its segment. This has a route to the inbound VPC. Because we're going through either NLB or an ALB, it's going to have the next hop be an IP in that inbound, and then traffic will go to that ALB and then out to the internet. So you'll notice here there's actually 3 routes egress. So one of the things that we add with Cloud WAN and when you build out a core network is the ability to have multiple routes, and we'd really recommend that you do have inbound and outbound VPCs per region to avoid latency and cost of going across regions. You certainly could, And actually, for a failover, if our local route were to get dropped from this route table, we could route this traffic over to another region. So there is some high availability built in, and availability in general, to using Cloud WAN as opposed if you were in just one region. You can handle that at the network layer. Another fairly common architecture is centralized outbound. So it can get expensive to deploy a highly available NAT gateway configuration in each and every VPC you deploy, especially at scale. So these type of architectures let you centralize that egress. And again, maybe you add in some inspection in that outbound VPC where you have firewalls or AWS network firewall to filter that traffic before it goes on out to the internet. So in this case, an instance in our dev VPC would just have a default route in the dev segment. And then we see, again, here we have 3 routes, 1 for each region. So if one of these were to fail over, it could go to another region. But following a best practice, we'll have an egress in that specific VPC. These are static routes. These are something you need to define and work through as you build out your network. But then we see that goes directly to the NAT gateway, to that core network edge. That core network edge has a default route to the NAT gateway. And then from the NAT gateway out to an IGW, an internet gateway, and then traffic can come back in. And then on the way back in, we have our dev and prod CIDRs, which have a route to the core network on the outbound VPC. And then from there, the traffic lands in the security VPC. We then have a route that's propagated to our dev CIDRs, and then we go directly to the dev VPC. So we've centralized that traffic. We can add additional security controls and monitor and filter that traffic and cut down some of the cost of deploying a highly available NAT or egress infrastructure in every VPC. Another kind of common infrastructure is an east-west inspection. And this is something that a lot of the concepts of doing this with Transit Gateway apply here. You notice there are a lot of static routes. I think the one bit of advice here would be to think hard if you need this type of inspection. We can certainly support it, and we'll see the flows get a little complicated. But if you have requirements where, and we'll see in this example, from a dev to a prod VPC, you want that to go through an inspection VPC, be it a third-party firewall or AWS network firewall, this type of architecture will support that. So from a dev VPC, we go to our dev segment. And in our dev segment, we here have a static route of our production VPC CIDRs. And then we direct that to our east-west inspection VPC, and this would have a fleet of firewalls behind it with gateway load balancer or other services. Then traffic coming back will go to the security segment. And here we have a static route, and this happens to be in other regions. So it's the east-west inspection in the other region. If it was in the same region, then obviously it would take one of the other routes and not go across the region. But in this case, we do need to double inspect here. Just for flow symmetry, you kind of can't have the traffic just flow back in. Firewalls are stateful, and they don't like it when traffic goes around them. So then from the east-west inspection in our second region, the traffic will hit its route table, and then here we hit a propagated route, and we'll go directly to the production VPC instance. Coming back, the traffic will hit its production segment. Here are dev VPCs, again, a static route, and that'll go to east-west in region 2, and then to our security segment with a static route to east-west in region 1. Hit that route table, and then go to a dev VPC. What could possibly go wrong? Now, this is a lot easier than some of the other inspection architectures that are out there, especially if you need to centralize this and do this at scale. It is certainly a solution to be able to do that. You might notice that this will work today within 1AZ. There is a feature, if you're tracking with Transit Gateway, called appliance mode, and that allows us to keep traffic within a single AZ, or spread traffic and ensure flow symmetry. What happens with this architecture, if you were to go and launch this today, is you'd get some asymmetric routing without the appliance mode enabled. That is a feature that will be coming out very soon. So we're working to get that released in the imminent future. So this will work end to end. So if you were to go try and apply this tonight, it wouldn't work if you're going across AZs. But once we have that feature in the coming weeks, that will work. Another pretty common infrastructure that customers integrate with is an SD-WAN, software-defined networking. Today with Transit Gateway, using Connect is a way that we get all of those routes from all the SD-WAN edges into the cloud. With Cloud WAN, we can do that globally, which adds a lot more feature and functionality here. The way this works is we have a VPC attachment to our SD-WAN appliances. We then have a prod VPC attachment and a dev VPC attachment. From our SD-WAN instances, we do a GRE tunnel, and we do route exchanges through BGP over that GRE tunnel. And then from your SD-WAN appliances, they just connect out over the internet to your branch offices and remote locations. So if an instance in my dev VPC wants to talk out to the SD-WAN edge, it goes to its route table, and then it just has the routes. They're right there. So then it just goes direct out through those appliances, through that infrastructure over the IGW. So it allows that traffic flow end-to-end and integrates your existing investment in SD-WAN, and we can take in a whole bunch of routes and exchange those routes. Each one of these attachments for the GRE tunnels is 5 gigabits a second, and you can have up to 4 of them. So you can get 20 gigabits a second per appliance. So it's super scalable in terms of bandwidth and being able to support it. You're probably going to run into bandwidth limitations on the instance long before you hit it on the core network side. So thinking through these individual components, tying them all together for an end-to-end architecture, once you deploy a core network, you can go ahead and deploy your segments and then attach your VPCs. AWS site-to-site VPN to connect your VPN sites and your branch offices. Then connect through a connect attachment, connect your instances to your segments. And here, using a hybrid VPC or a hybrid segment gives you that kind of end-to-end routing to be able to propagate those routes into your other segments. And then we can connect to our SD-WAN sites. We can then do a VPC attachment and use something like AWS Client VPN or a third-party appliance, and then have all of your remote users connect in from wherever they are and land on their own segment, so we can further control their traffic and where they can go to and how they can get there. And then for our physical fiber sites, we can have a Transit Gateway attachment with the Direct Connect Gateway, and then all of our sites connect together. And we can further enable SiteLink and have end-to-end connectivity between our Direct Connect sites. So if you look at this architecture, we only have 3 Direct Connect locations, but we've built out an entire global WAN. A lot easier said than done, but you can do this in a single policy and deploy this in a CloudFormation script and build out your entire global WAN. So definitely a great feature enhancement and improvement to kind of some of the constructs that we've been working on, kind of the latest generation of what we've built. So we can deploy this at scale with sharing. So if we'd recommend building this in a dedicated network account. You can have app accounts and then share it out. And then from those app accounts, they just simply attach to the core network. And based on tag or how you've done your attachment policies, they'll automatically be able to connect and route throughout your network. This is going to be through Resource Access Manager, RAM, through AWS organizations. So you can share out that core network to an individual account ID, to an organizational unit, or to your entire AWS organization, depending on your account structure. So if we look at this in action, we can see we have a core network. This is a subordinate account. Because I've shared my core network with that account, it shows up in the console or also the CLI. I've also can use the name to map it to a segment. In this case, I've chosen dev in the name. I've then created a rule that says if it contains dev, it's going to go into a dev segment. And then we can see on this bottom what the network admin would see in the networking account, that it's already mapped to that segment, but it's pending attachment. So I'd go in and approve that, and then my VPC is able to talk to the rest of the network in the proper dev segment. So now that we've built all this, we do have some visualizations built in because this uses our network visibility suite. We can see an overview of the end-to-end network. We can see a topology and dig into individual segments and our global WAN, zoom in, zoom out, across Transit Gateway and Cloud WAN. And then we have a detailed log of all the events and everything that's happened. We then get into our network visualizations. We have a dashboard that you can bring up. This might be something you throw up on a NOC. We're able to see our entire end-to-end network and a topographic view of everything across our entire network. And with that, I'll hand it over to Sid to see a demo of this in action.
Awesome. Thanks, James. So for demo, I've divided this into multiple scenarios. Scenario 1 is where John Doe has just joined an organization and is tasked with managing its existing global network. So John is going to leverage the rich visualization capabilities of Cloud WAN. So let's look at that in action. So I'm in the Network Manager console, and I already have a global network configured. So I'm going to go ahead and jump into my global network. Here I am greeted with a geographical map, and I can see I have presence in 3 AWS regions, or 3 regions: US East 1, EU West 1, and AP South and Mumbai. Now to get more details, I jump into topology tree, enable the segment view. Now I can click on individual regions and see details about it. Here I'm looking at metrics like bytes in, bytes out, packets in, packets out, as well as James mentioned, all the events. Here I have an event where I've created BGP peering with SD-WAN appliance. I have 4 segments. I can click on individual segments, and it gives me which segments this segment is shared with. In the hybrid segment, I have a connect attachment. This is what the BGP peering was established with. I have 2 BGP peers, and the BGP status is up. Now I move down in my topological graph, and I can see for US East 1, I have 4 segments, but instead of the hybrid segment, I have an external segment. In EU West 1, I have 3 segments: shared services, prod, non-prod. So no external segment and no hybrid segment. Now to get more details on my global network configuration, I jump into my network policy. Here I can see I have AS ranges. I have inside CIDR blocks for my GRE tunnels. 3 edge locations, which we've already looked at. I have 5 segments configured: external, hybrid, non-prod, prod, and shared services. And for external and the prod segment, I require attachment acceptance, right? So a human approval required for associating networks to it. For external and prod, for shared services, I have isolate attachments. So attachments cannot talk to each other. Then I have my sharing. I have hybrid and external shared with non-prod segments, and shared services shared with prod and non-prod segments. I have 2 static routes defined. This is in the prod and non-prod segment, where I'm saying, hey, all the default traffic goes to these specific VPCs. These are my shared services VPC. Finally, I have a bunch of attachment policies, but instead of diving into these attachment policies here, I'm going to take you into the JSON version of it. I'm going to copy it out into my favorite JSON editor. On the left, you can see I have segment actions, and attachment policies. So I have 5 segments defined. Then in the segment action, the first one and the second one is for the static route. The 3rd, 4th, 5th one is for sharing the routes between segments. Now the first attachment policy says, hey, if the attachment is coming from an account ID which equals to this value, automatically attach it to the external segment. The second one is for tag-based automation. The 3rd, 4th, and 5th one is using resource ID, which is a VPC. So I exactly know what the VPC ID is, and based on that, I'm attaching it to the shared services segment. And finally, I have a hybrid segment, which I'm again attaching using tag-based. So based on that information, I can create my network architecture. So I have a core network with 5 segments. Now, based from the topological graph, I know exactly which attachments are connected to which segments, and I also know how the segment sharing works. So I can populate all of that into this diagram. Now, in scenario 2, the external VPC belongs to a partner, and it's sending some unusual traffic. So I'm going to go ahead and isolate the external segment. So if we jump back into our architectural diagram, you can see our external segment is sharing routes with non-prod, and this is what I want to disable. So I'll go into my network manager, go into routes, and check what routes already exists here. So in the external segment in US East 1, I search routes, and I can see 3 routes here. These are the non-prod VPC CIDR ranges, which are being propagated into the external segment. Now let's go ahead and look at the non-prod segment in US East 1. And I can see 10.128.128.0. That's the CIDR range of the external VPC, and this is propagated into the non-prod segment. So this is what I want to get rid of. So to do that, I'm going to go back into my policy, locate the live policy, and edit it. Now, if you remember, route sharing works through segment actions. So I'm going to jump into my JSON and find that action, and there it is. So non-prod shared with external, I'm going to highlight it, and I'm just going to delete this. I'll go ahead and create the policy. It's ready to execute. I'll click View Apply Chain Set. Now I can see exactly what I'm changing in the network, the previous value and the new value. previous value, it says external segment is being shared with non-prod, and the sharing is removed. You can see it's null. And this is shown on a per core WAN edge location basis, right? So for every region. Now, I also have attachment route propagation, previous values where the propagation is taking place, and the new value, I'm basically just removing it. So I make sure everything looks right, and I apply the chain set. I'm going to wait for it to get executed. Perfect. Now I'm going to go and verify this in my route table, and hopefully everything worked well. So I'm going to go and open the external segment route table in US East 1, and there are no routes. Perfect. Let's just verify that in non-prod as well. Yep. The 10.128.128 route is no longer there, right? So we have achieved what we set to do. Now, in scenario 3, let's look at how you can integrate Transit Gateway with the global network, and then migrate VPCs attached to Transit Gateway from Transit Gateway to the global network, right? Now, this can also be the scenario where you're acquiring a new company and you want to integrate their Transit Gateway with your existing global network, whatever the case might be. So we have our existing setup. Let's bring in a Transit Gateway. As James mentioned, the first thing we need to do is peer the Cloud WAN to Transit Gateway. Next, we'll create individual route table attachments and associate them with the appropriate segment in Cloud WAN. Let's do that. So here I'm on the Transit Gateway console. I have a Transit Gateway. I'm going to look at the route tables. I have the prod and the dev route table. That's the one I'll be associating. Let's look at attachments. I have 2 VPCs, one in dev and one in prod. Perfect. Now I'm going to go back to my network manager, open the global network, and create the peering between Transit Gateway and Cloud WAN. Give it a name, Transit Gateway peering. Edge location, my Transit Gateway is in US East 1. I create a new policy table. A policy table is used for dynamic routing between Cloud WAN and Transit Gateway. You don't have to do anything. It's all handled behind the scenes. We go ahead and create the peering, wait for it to get completed. Now, once the peering is done, next step, step 2, create attachments. So we're going to go back into the Attachments tab and create a new attachment. Now, we'll first attach the dev route table, edge location North Virginia. Attachment type is Transit Gateway route table. Select the peering we just created, and we'll select the dev route table here. Now, we want this to be associated to the non-prod segment, so we'll appropriately tag it, and the automation is going to do rest. Go ahead and create it. Now, we'll create the next attachment. This will be for the prod route table. Edge location, Northern Virginia. Attachment type, Transit Gateway route table. Select the peering. And here we select the prod route table. Now, we want this to be attached to the prod segment, so we'll appropriately tag it, assign to prod. And we go ahead and create it. Now, if you remember, prod segment required attachment acceptance, so we'll have to go ahead and accept this attachment request. Right? Additional human verification. We go ahead and accept it. Once we do this, we'll see now both of those attachments are in creation mode. We'll wait for them to get created. Yes, they are available. Perfect. Now we can go and check if we are learning any new routes from Transit Gateway. So in the non-prod US East 1, let's search routes. As we scroll down, we can see 10.51.00/24. That's the route which we are learning from Transit Gateway. We can verify this by going into the dev route table of Transit Gateway. Here we can see we have learned a whole bunch of routes from the core network, and all of this is automatically propagated into the dev route table of Transit Gateway. Let's do the same for the prod segment. So we'll open the prod segment, US East 1, search routes, and we can see we have 10.200.00/24. Let's go back to Transit Gateway route table and look at the routes. We can see that 10.200.1, which is being advertised into global, into Cloud WAN. In addition, we can see all these core network routes which we have learned from our Cloud WAN core network into Transit Gateway routing table. Perfect. Now the physical setup has been done. Transit Gateway is connected. So what's left? Let's start pinging and verifying that everything's working fine. So for that, I have created a EC2 instance in my old dev VPC, and I'm going to try and ping the 10.64.100.0/24 network, which is a remote network attached to my SD-WAN appliance. So the 10.51.00/24, that's the network, right? Just verifying that it's attached to my dev route table in Transit Gateway. I have an EC2 instance running, 1051.0.23. I'm ready to ping. Just to verify, in the core network hybrid segment, I have 164 network, which I am getting from my connect attachment. That's my SD-WAN appliance. And this is my SD-WAN appliance. I have the 164 in one of my interfaces. So let's go ahead and do the ping. Awesome. So we are able to ping, and we are seeing a 189 milliseconds round-trip latency because we are pinging from Northern Virginia to Mumbai. Now let's keep the ping going. And we are going to start migrating the VPC from Transit Gateway to Cloud WAN. So for that, step one, create an attachment from your old dev VPC to the Cloud WAN core network and associate it to the non-prod segment. Now, once you do that, there is asymmetric routing here. How? If you see the old dev VPC route table, it's still sending all traffic to Transit Gateway. So in these pings, the ping request goes via Transit Gateway. But the ping response actually goes directly from Cloud WAN through the attachment we'll create to the old dev VPC, right? So there's some kind of asymmetric routing happening here. So to get rid of that, we have to change the old dev VPC subnet route table to send all traffic to core network. Once that's done, everything's working, we can go ahead and delete the Transit Gateway attachment. So let's see that in action. So step one is to create the attachment from old dev VPC to core WAN, to Cloud WAN core network. So we go ahead and do that. It's in North Virginia, VPC attachment, old dev VPC, Transit Gateway VPC. We select the right subnets. We have to assign this to the non-prod segment, so tag it appropriately. We'll wait for this to get created. OK. Now, we can go and see that our ping is still working, right? We did not lose any packet. At this moment, the transitive routing, the asymmetric routing has begun. And to verify that, we can go back into a core network route table, into the non-prod segment in US East 1. And now we can see the 1051 route now points directly to a VPC attachment. Earlier, it was pointing to Transit Gateway. So the core network of Cloud WAN is sending traffic directly to the VPC, while the VPC is still sending traffic to Transit Gateway. And we can verify that by looking at the VPC subnet route table, which is right in front of us. If we go to the routes, we can see there's a route 164.0/16, which points to Transit Gateway. So we're going to get rid of that. And instead of Transit Gateway, we will force the VPC to use the core network. We go ahead and do that. And we go back and check our ping, and we can see it's still pinging. Now we have successfully migrated the VPC from the Transit Gateway to the Cloud WAN core network. And doing this, we did not lose a single ping, so it's quite seamless. So next, I'm going to hand it over to James to talk about best practices and wrap this session up. Oh, sorry.
OK, so we wanted to wrap up with some best practices for you to walk away with. So first and foremost, tag attachments. That's really the beauty of the policy engine that we bring to the table with Cloud WAN. Add to edge locations as needed. There's a charge for having a core network in an edge location. So obviously, if you don't need every region, don't have every region. Deploy Cloud WAN in a dedicated networking account, especially in large organizations. It might make sense to segment that out to give your network team access to just that component that they need access to. Integrate with RAM, Resource Access Manager, and AWS Organization so you can have governance and sharing at scale. Separate ingress from egress. This allows you to scale and build your ingress and egress patterns separately. General best practice. Regionalize your shared services. Make sure that you have these shared services in each and every region you want to operate in. Adopt as appropriate. So if you have transit gateway architectures today, we're not saying rip it and rebuild it, but as you look towards the future, look at Cloud WAN, and especially if you're going to be growing globally, Cloud WAN might be the answer for you. And then plan for growth and agility, and create dedicated subnets for the VPC attachments to the core network, similar to how you create a dedicated subnet for the attachment to a transit gateway. /28 works just fine. So thank you. We'll stay on for Q&A, but feel free to reach out to either of us and fill out the survey. Your feedback's really important. Hopefully you enjoyed the last hour and this was very useful. We have mics, one right there and one right there, so if you want to line up.